Today we are going to deal with the Ramsey test. Ramsey test. Well, Ramsey test is basically a test which is used for the omitted variable test. It is a kind of omitted variable test, and whenever there is a functional misspecification of a regression equation, that is, suppose the regression was supposed to be y equals to alpha plus beta x square plus the error term, and by any chance or by any misspecification, someone has fitted the model as y equals to alpha plus beta x plus ui. So this is basically a misspecification because the model was supposed to be a non-linear model, but by any mistake of the problem setter, he or she might have chosen a linear version of the model. So that is basically a misspecification, and when there is a misspecification, functional misspecification of a regression equation just like this, at that particular point it may lead to heteroscedasticity. Okay, so when there is a functional misspecification of a model, then it may lead to heteroscedasticity. And similarly, if there is correct or if there is explanatory variables, suppose there are two explanatory variables, y equals to alpha plus beta x1i plus gamma x2i. Now if I by any chance omit this x2i, this is obviously an explanatory variable, and if I by any chance omit this explanatory variable from the model, and if I write the model as y equals to alpha plus beta x1i plus plus the error term, and I have omitted this x2i variable. Now in this type of cases, when we are actually omitting any explanatory variable, then that may lead to autocorrelation. Okay, that may lead to autocorrelation, and that may also lead to biased estimates. So these two things are very important, and these two things for getting rid of the problem of these two things, we are actually incorporating the Ramsey test. So what are the two problems that can happen? When there is misspecification of a model, then it might lead to heteroscedasticity, and when there is a problem of incorrect omission of explanatory variable, then it might lead to autocorrelation or biased estimate. So in this type of problem, for detecting this type of problem, we are actually going to apply the Ramsey test. Okay, so Ramsey specification test or Ramsey specification error test is based on adding a variable to the initial regression model. So basically, suppose we have a model that is y equals to x beta plus epsilon. Now this is our model, this is our initial model, and in for applying the Ramsey test, we have to actually this is our initial model, and for applying the Ramsey test, we have to actually add a test variable to the initial regression model. So suppose we have a test variable that we want to add in the initial regression model, and it might be I am adding that variable. But before adding that variable, let me tell what we are supposed to do after adding the test variable to the initial regression model. Now after adding the test variable to the initial regression model, we have to test the corresponding coefficients, whether they are significant or not. So basically, after, suppose we have a test variable that we have added, that is z, that is called z, and so there will be a coefficient of z, that is gamma, and after adding this test variable, we have to test that whether this coefficient of the test variable is statistically significant or not. If it is statistically significant, then we have to just basically we are going to set up the hypothesis on the basis of that. Okay, so if it is statistically significant, that means there was a specification error, and if it is not statistically significant means if it is equal to 0, then we have to say that there was no misspecification and the functional form was absolutely correct. But if it is not equals to 0, then we have to say that there was a misspecification in the model and there was a specification error that was committed. So we have to set up the null hypothesis and alternative hypothesis on the basis of that. I am going to do all of that step by step, but before going into that portion, let me tell you the process of leading into it. So basically we have a model that is y equals to x beta plus epsilon. Now if I take the estimated version of the model, then it becomes y equals to x into b. Now here this b is the estimator of beta, obviously b is the estimator of beta, and what is y hat? Y hat, it's nothing but it is the predicted values of actual y. Okay, so y hat is the predicted value for actual y. Okay, so now basically we are going to take or we are going to raise the power of y hat. Okay, so we raise the elements of y hat, I mean to say we are basically having we are having the values of y hat, that is y hat, y hat, y hat, and we are going to assign powers to each of the values of y hat, and we are going to make a matrix with it. So basically the first one is y hat square, y hat cube, y hat 4, y hat to the power 5, and it goes on y hat to the power 6, it goes on like that, and it eventually ends at y hat h plus 1. So this is basically a value of y hat, and each of the value of y hat assigned with continuous powers, and we have a matrix of that values. So we are naming that matrix as z, and now we are going to add the z into the initial regression model. So what was our initial regression model? It was y equals to x beta plus epsilon, and we are going to add the value of z in the initial regression model, and it will obviously, the z will be assigned with a coefficient, and we are taking that coefficient as gamma, so it will be gamma z plus epsilon. Now this is the model setup, and this was the process that I was talking about, that we have to add something in the initial regression model, and we have added actually this z, and this z is formed upon by the values of y hat and assigned with continuous powers. Okay, now what will be our null hypothesis? This is the step 1, basically our null hypothesis and alternative hypothesis. Null hypothesis tells us that gamma equals to 0, and if gamma equals to 0, then there is no difference between the actual model and the initial model and the setup model. The initial model and the newly set up model, there is no difference if gamma becomes 0. Okay, so if gamma equals to 0, then we can say that there was no problem in the model, and the model was absolutely correct, and the functional form of the model was absolutely correct. So we may say that there is a correct functional form in the model, and if h1 is saying that gamma not equals to 0, then there was obviously a misspecification error. That means there might have some variable that we have missed in the model, and we have committed a specification error. The model is not correctly specified here, so there are some specification errors. Now specification errors. Okay, now in the next step we have to calculate the Ramsey test statistic. So Ramsey test statistic is basically a F test statistic. So how we can define it? Ramsey test statistic can be defined as F equals to SSR minus ESSR divided by H, ESSR divided by T minus K minus H. Okay, now here this SSR is nothing but it is the sum of squared residuals, and ESSR is nothing but sum of squared residuals from the OLS estimation of the extended regression model. So what is SSR? SSR is let me change the color. SSR is nothing but it is the sum of squared residuals from the OLS estimation of the regression model y equals to x beta plus epsilon. So this is our actual regression model or initial regression model. So when we are actually calculating the sum of squared residual from the initial model, then that is termed as SSR, and when we are actually taking the extended sum of squared residual, then that is denoting the sum of squared residuals calculated from the extended regression model, that is y equals to x beta plus z gamma plus epsilon. Okay, and this part of the formula, H is the degrees of freedom for the SSR minus ESSR, and T minus K minus H is the degrees of freedom for ESSR. Okay, so that's how we are supposed to calculate it, and this is how it should be done. And the last step, that is, there might be a table value, the tabulated f, and we all know that if f tabulated and f calculated, we have to compare. Okay, so we have to compare this f calculated and f tabulated. This is basically f calculated. The from this formula, the value you obtain, it is basically the calculated f. So if f calculated is greater than f tabulated, then we are actually rejecting the null hypothesis. Reject A0, or it is better if you say that we are failed to accept null hypothesis. It is much more required if you, or it is much more better version if you say that we are failed to accept the null hypothesis, or we are rejecting the null hypothesis. And if f calculated is less than f tabulated value will be given, or you may find it in the internet, or there is f table of f anywhere if you find it in the internet. So if f calculated is less than f tabulated, then we are accepting the A0. So this is the entire process of the Ramsey test. I hope you are satisfied with the video. The next video that will come is will be on the Jarki-Vira test, which is basically a test for normality testing.